Hey everyone, welcome back for another deep dive.
Excited to be here.
Today we're tackling something pretty massive, literally.
Oh, yeah.
We're talking about the vastness of the universe.
Okay, the big one.
And we've got this great episode of Beyond the Stars to guide us.
Dr. Foster and Dr. Ramesh, they always bring the cosmic heat.
Absolutely. So much good stuff in this episode.
Definitely.
Like, right off the bat, Dr. Foster just casually mentions the observable universe is 93 billion light years in diameter.
I mean, that number alone, right?
It's almost impossible to even picture 93 billion light years.
And that's just what we can see, like it's a snapshot.
Exactly. And as far as we know, the universe might just keep going infinitely.
Like an endless sheet of paper. That's how I try to think about it.
And on that sheet of paper, 2 trillion galaxies.
Dear tree.
Each one with hundreds of billions of stars.
It's crazy to think about.
And speaking of those early days of the universe, the podcast talks about the cosmic microwave background radiation.
Oh, yeah, the CMB. It's like a baby picture of the universe.
Literally light from the Big Bang, from 13.8 billion years ago.
It's everywhere, this faint glow, and it tells us so much about how the universe began and how it's structured.
Now, here's something that really got my attention. NASA estimates billions of Earth-like planets in our galaxy alone.
Billions.
So that means there are planets out there potentially in these habitable zones where liquid water could exist.
It makes you wonder what those planets might be like.
And then it makes you think, where do we fit into all of this?
Right, like zooming out to the bigger picture.
We're on Earth, which is part of our solar system, obviously.
So far, so good.
But then our solar system is just one tiny part of the Milky Way galaxy.
One among billions of stars.
And Milky Way is part of the local group of galaxies.
It's like a little neighborhood.
And then the local group is part of the Virgo supercluster.
Which itself is part of an even bigger supercluster, Laniakea.
It's mind-blowing how everything is nested within these larger and larger structures.
It really gives you a sense of scale.
And with all these stars and galaxies out there, you'd think the universe would be jam-packed, but it's actually mostly empty space.
Yeah, it's weird to think about.
And most of it isn't even made up of the stuff we can see, like stars and planets and gas.
Right. That's only about 5% of the universe.
The rest is dark energy and dark matter.
We can't see them directly, but we know they're there because of their effects on things we can see.
Like dark matter's gravity holds galaxies together.
And dark energy is thought to be pushing everything apart, making the universe expand faster and faster.
They're both huge mysteries.
Totally. So scientists are still trying to figure out exactly what they are and how they work.
Now, speaking of mysterious objects, Dr. Ramesh in the podcast really dives into black holes.
They're fascinating, these regions of space-time where gravity is so strong that nothing, not even light, can escape.
And there's a supermassive black hole at the center of our own galaxy, Sagittarius A.
4 million times the mass of our sun.
Imagine the power of something like that.
It's really hard to comprehend.
So, with all this vastness and all these planets, the question always comes up, are we alone?
The big question.
And this is where the Fermi paradox comes in, right?
If the universe is so big and so old, why haven't we found any aliens yet?
Dr. Foster offers some possible solutions in the episode.
Like maybe intelligent life is just incredibly rare.
Or maybe civilizations tend to destroy themselves before they can make contact.
Or maybe they're out there, but they're choosing to stay hidden.
Maybe they're watching us right now.
Who knows? It's all speculation, but it's fun to think about.
And while we haven't found any aliens yet, we're still looking.
With projects like the James Webb Space Telescope and SETI.
And honestly, just the fact that we can have this conversation is incredible.
Here we are on this tiny planet contemplating the universe.
It really makes you think about our place in the cosmos.
And it's amazing how much we've learned, but also how much we still don't know.
That's what I love about this topic. There's always something new to discover. And Dr. Ramesh, she has this great quote in the podcast that really stuck with me. She says, for me, it's the realization that every atom in our bodies was forged in the core of a star. We're literally made of stardust.
It's profound when you think about it.
We are literally connected to the universe on a fundamental level.
It's like we're all part of this giant cosmic story.
So that makes me wonder, if we were to actually encounter another intelligent civilization out there, what would be the first thing you would ask them?
Wow, that's a tough one.
I know, right?
Yeah.
So much to ask.
I think I'd want to know how they view their place in the universe. Like, what's their perspective on all of this?
That's a great question, to get a sense of their understanding of everything.
Yeah, and maybe it would give us some insights into our own place as well.
Okay, so we've covered a lot of ground here in part one. From the mind-blowing size of the observable universe to the mysteries of dark matter and dark energy, and even touched on the possibility of extraterrestrial life.
And we've just scratched the surface.
But that's the story for part 2 of our deep dive.
I can't wait to keep exploring.
Me neither. Stay tuned.
We'll be right back.
Back again, ready for more cosmic exploration.
Always ready.
You know, that idea of billions of Earth-like planets, it's just wild to me.
It's really something.
Like, statistically speaking, it seems impossible that we're completely alone in the universe.
Right. But then we have the Fermi paradox.
That's the head-scratcher. Why haven't we found any evidence yet?
Exactly. If there are so many potential civilizations out there.
Dr. Foster and Dr. Ramesh in the podcast, they had some pretty interesting theories about that.
Oh, yeah. Some wild possibilities.
It's like a cosmic mystery.
Definitely.
Okay, remind me, what were some of those potential solutions to the Fermi paradox?
Well, one idea is that maybe intelligent life is just incredibly rare.
So we could be one of the first.
Potentially, yeah, like we're the pioneers.
Wow, that's kind of a cool thought.
It is, but it also means a lot of responsibility.
Oh, yeah, true. If we are the first, then it's up to us to figure things out.
Exactly. No pressure, though.
None at all.
But there's also that other side of the coin. Maybe intelligent life isn't rare, but it's prone to self-destruction.
Oh, yeah, that's a bit darker.
Right, like maybe it's in our nature to destroy ourselves before we reach a certain level of advancement.
They even mentioned the Great Filter. Like maybe there's some kind of obstacle that most civilizations can't overcome.
It's a scary thought.
It is, like a cosmic test that most fail.
And we don't even know what the test is.
Or if we've passed it yet.
Exactly.
It's all pretty thought-provoking. But I appreciate Dr. Ramesh's point in the podcast that even if we don't find definitive proof of aliens, the search itself is valuable.
Absolutely. It's pushing the boundaries of our knowledge.
And it's making us think about the universe in new ways.
For sure. And that's what science is all about.
So, okay, remember how we talked about the universe constantly expanding?
Yeah, driven by dark energy.
Right. Well, they also touch on the idea that it might not expand forever.
Oh, yeah, like the universe could have an ending.
Exactly. And there are a few different theories about how it could all end.
Cosmic endings. It's kind of mind-blowing.
I know. So let's hear it. What are the possibilities?
One scenario is the big freeze.
Okay, tell me about that one.
So if dark energy keeps pushing everything apart, eventually galaxies will be so far away from each other that even light won't be able to travel between them.
So everything just keeps getting further and further apart?
Yeah, and the universe becomes this cold, dark, and empty place.
That's a bit depressing.
Yeah, not the most cheerful outcome.
Okay, what's another possibility?
The big crunch.
Okay, now that sounds more dramatic.
Right, so in this scenario, the expansion of the universe eventually slows down and reverses.
So instead of expanding, it starts contracting.
Exactly, and everything starts to come back together.
Like a reverse Big Bang.
Kind of, yeah, and ultimately everything collapses back into an infinitely dense point.
Wow, that's intense.
Definitely more exciting than the big freeze.
Okay, so we've got freeze and crunch. Is there another option?
Oh yeah, they saved the most dramatic one for last. The big rip.
The big rip, that sounds ominous.
It is. So in this scenario, dark energy gets stronger and stronger over time.
Okay, and?
Well, eventually it becomes so powerful that it overwhelms all the other forces in the universe.
Like gravity.
Yeah, everything. And it starts to tear apart everything. Galaxies, stars, planets, even atoms.
So like the universe just unravels.
Basically, yeah, everything dissolves into nothingness.
Okay, that's officially the most terrifying scenario.
It's definitely the most intense.
So we've got a universe that could freeze, crunch, or rip itself apart.
Those are the main contenders.
That's a lot to think about.
It is, but the good news is none of these endings are happening anytime soon.
So we've got some time to enjoy the show.
Exactly. Billions, maybe even trillions of years.
Okay, that's reassuring.
Plenty of time to keep exploring and learning.
And who knows what we'll discover along the way.
That's the exciting part.
Speaking of exploring, next time we're shifting our focus to something a bit closer to home. Our own galaxy, the Milky Way.
The Milky Way, our cosmic home.
From supermassive black holes to dazzling nebulae, it's full of wonders.
I can't wait to dive in.
Get ready for a cosmic sightseeing tour. All right, we're back.
Ready for the grand finale.
After exploring the vastness of the universe, we're zooming in.
To our own backyard, cosmically speaking.
The Milky Way galaxy.
Our home, sweet home, among billions of stars.
It's incredible to think our sun is just one star among all those out there in the Milky Way.
It really puts things in perspective.
So paint me a picture. What exactly is the Milky Way?
Imagine a giant disk 100,000 light years across.
100,000, wow.
Yeah, and it's a spiral galaxy.
I've seen pictures, those beautiful spiral arms.
Exactly, those arms curve outward from a central bulge.
And where are we in all of this?
Our solar system is about 2/3 of the way out from the center.
Tucked away in one of those spiral arms.
Right, and at the very center of it all, there's something we've talked about before.
You mean the supermassive black hole?
Sagittarius A, the heart of our galaxy.
Millions of times the mass of our sun.
Hard to even imagine.
And I bet there are other fascinating objects out there in the Milky Way, too.
Oh, absolutely. We've got star clusters, these groups of stars that form together.
Like little families of stars.
Kind of, yeah. Some are really dense with thousands of stars packed together. Others are more spread out.
And what about those nebulae, those colorful clouds of gas and dust?
They're amazing. Those are like the art galleries of the galaxy.
I've seen pictures so vibrant. What makes them so colorful?
It's the elements within them and the radiation from nearby stars.
So different elements create different colors.
Exactly, and that's why we see those stunning reds, blues, greens all mixed together.
It's like a giant cosmic painting.
And they're not just pretty to look at. Nebulae are also where new stars are forming.
So they're like stellar nurseries.
Exactly. It's this amazing cycle of birth and death, old stars dying and new ones being born.
Kind of poetic when you think about it.
It is, and it makes you wonder, how did the Milky Way itself form?
Yeah, how did all this come together?
Well, like most things in astronomy, it's a long process, billions of years in the making.
So start at the beginning.
Okay, so basically, it all started with a giant cloud of gas and dust.
And gravity did its thing.
Exactly, pulling everything together, and eventually this material clumped together to form stars, and over time, the structure of the Milky Way emerged.
But it's still evolving, right?
Oh, yeah. The Milky Way is constantly in motion. It's spinning, with everything orbiting around that central black hole.
And we're just along for the ride.
Exactly, and it's not just spinning. The Milky Way is also interacting with other galaxies.
What do you mean interacting?
Well, sometimes galaxies collide with each other.
Wait, collide? Like a car crash?
And not exactly. It's more like a slow-motion merger over billions of years.
So it's not like a sudden impact?
No, it's a gradual process. The galaxies kind of dance around each other, their gravity pulling on each other, and eventually they merge together.
And this is actually going to happen to the Milky Way?
Yeah, we're on a collision course with our neighbor, the Andromeda Galaxy.
When is this supposed to happen?
Not for a while, about 4.5 billion years from now.
Okay, so we've got some time.
Plenty of time, but when it does happen, it'll be quite a show. The two galaxies will merge to form one giant elliptical galaxy.
So the Milky Way as we know it will cease to exist.
In a way, yes, but it will become part of something new and even more massive.
Wow, that's kind of mind-blowing, the idea that everything is constantly changing, even on a galactic scale.
It is, and it makes you appreciate how dynamic the universe really is.
It really does. So we've explored the mind-boggling size of the universe, the possibility of alien life, the mysteries of dark matter and dark energy, and now we've journeyed through our own galaxy, the Milky Way.
It's been quite a ride.
And you know, it's left me with a sense of awe and wonder, and a desire to keep learning more.
Me too. And that's what we hope you take away from this deep dive, a sense of curiosity, a thirst for knowledge, and a renewed appreciation for the universe we call home.
It's a universe full of beauty and mystery, and it's waiting to be explored.
So keep looking up, keep asking questions, and never stop exploring.
Thanks for joining us on this cosmic adventure. We'll see you next time.
Until then, keep exploring the universe.